A package arrived from the Netherlands. This can only mean one thing. It's a board from the Embedded Hardware CTF by Riscure. So let's see what's in there. We got a couple of stickers, very nice, and an anti-static bag with the Arduino board. Let's remove the staple and see inside. So we got a couple of connectors that we can solder to the board and the board itself. As you can see, the board has a mini USB connector, a reset button, 4 LEDs and several connectors. We should solder these connectors to the board in order to be able to more easily attach cables if needed. And we can stick it onto a breadboard. To solder the board, I use a third hand that holds the board for me. I apply some soldering flux, which helps, and then I simply apply some solder. So now we got the long row. Please don't judge my solder job, I know it's a bit crooked, I don't do this a lot. And then we turn the board around and connect the other 6 pins to stick out the other direction. Once we are done, we can place the Arduino board on a convenient breadboard, which is great to attach other wires and so forth. But turns out I suck at soldering and it's so crooked that I can't really get the board in, so I use a paper towel to cushion the pressure a bit and apply some force to get it in there. Then I do some sanity checks to make sure I didn't accidentally connect ground with another pin that shouldn't be ground. If you hear it beeping, that means these pins are directly connected, but these ones are all fine. Now let's have a closer look at the board. We can remove the sticker from the microcontroller to reveal the exact model number. And we start collecting information about the board that might be important later. For example, knowing the exact chip identifier, we can look up the datasheet and learn more about the hardware. So here we got an Atmel Mega or Atmega 328P. I mean, this is not surprising. We already know that the embedded system is an Arduino Nano from the CTF description, but it's good to know. We also might understand now that this is actually not an official Arduino board from the Arduino company, but an Arduino compatible board based on the Open Arduino design. So now let's get really started. Let's put the stickers that came with the board onto our laptop to make this legit. Now we are allowed to connect the board with a mini USB cable to our laptop. The green power LED is turned on and the red LED is blinking slowly, indicating that it's working. Now we can log into the CTF website, but before we can start with the challenges, we have to personalize the board. So the board is preloaded with a custom bootloader which is capable of decrypting the challenge binaries and flash them onto the board. To tell the bootloader the personal secret key, we have to flash this personalization binary. At least that's what I think it does. I think this binary might be encrypted with a master key that is known to all bootloaders, or simply obfuscated, and it will then place our real personal key somewhere into the board. Maybe it overwrites parts of the bootloader data or gets burned into it another way. I don't know. To load this binary onto the board, we have to run a program called avrdude, which is a program that allows to flash code onto microcontrollers. Riscure already tells us how to do this. We have to run avrdude, tell it that it's an Arduino board, the processor type Atmega 328P, which we already know, then the connected serial USB device, the baud rate for the serial connection, some other flags, and at the end the flash command to flash the setup.hex, that is the personalization binary. I think the easiest way to get a working avrdude setup is to simply download the Arduino IDE, which is used normally to write and program Arduino boards. It contains an avrdude binary and config already. Okay, now that we have installed Arduino, we can look for the binary in the application package, and there it is. Now we need to find the device to communicate with it. We can save the current list of devices in /dev and then connect the board. Do it again and diff these two to find which is the correct connected USB serial device, but it doesn't show up. This means that I don't have a compatible driver that can communicate with this USB serial chip. What we can do is check the device manager and have a look at the connected USB devices, and we will find a USB 2.0 serial device that is what we want to talk to. And it has here a product and vendor ID. Each USB device has that, and when you plug a device in, your system will check if it has a driver that can communicate with this particular device. In our case, it can't find the working driver, but we can use these now to search online for a driver that supports this product. And we find other people having the same issue, and we get links to this Chinese vendor site with a driver to download. So the trick to not get compromised from a shady Chinese driver that you are going to install with very high privileges, which you download over an insecure HTTP connection, is to just do it very, very fast, so that your brain can't tell you not to do it. Click faster, faster, click, go, go. And maybe you have to disable even more security mechanisms to load this shady driver. Once you did that, and you feel a bit dirty, you can check again the devices under /dev, before and after you plug in the board, and there it is. A TTY and a CU USB serial device. Now you can also start the Arduino IDE and it will show you an available board on this port. I added an alias for the avrdude binary because it's in such an obscure long path. Also, you probably need to specify a config file, which is also somewhere in the Arduino directory, so I added that one as well with -C. Now you can flash the personalization binary. Cool! And next we can flash our first challenge. I suggest to go with the secure file system. It's the first one I had a look at and you can use it to learn how to communicate with the board properly. Because that is already a first challenge. I'm sure most of you will run into the issue to not be able to send something, but you can figure it out. Your board is not broken. You should also join the IRC channel rhme on Freenode. There's a lot of hardware reversing talk going on, and I'm sure after the competition is over in February, a lot of write-ups and explanations will be happening there. Okay, good luck to all participants. I hope we all will learn more. Thanks to Riscure and specifically the people who worked hard to create the CTF. I'm really looking forward to this and I hope I will solve at least some challenges.